Oh, well, that is interesting.
Welcome back. And today I got something a little different for you. Today we're testing out some reinforced concrete. We want to see how impact resistant we can make this. Not just can it stop a bullet, but can it stop multiple rounds from a bullet. Now I'm editing the video and I noticed that I may have over-explained the initial intro, so I'm here to redo this. Today we're testing out ballistic concrete mixes, essentially. They're all higher performance reinforced concrete mixes, with one being ultra high performance. And the difference that makes it ultra high performance is that it has a compressive strength of 20,000 psi, whereas the other high performance concrete mixes are anywhere from 10 to 12,000 psi. Now, all these mixes have fiber reinforcement and other additives to achieve, higher levels of impact resistance. These mixes also utilize layering material to reduce the penetration and spalling. And if you'd like to see how I mix these or the formula I use, please comment below. And if enough of you, want to know, I'll make a separate video for that. So our goal is to be able to stop multiple hits from a 308 fired from 15 yards in a 2-inch thick block of concrete, or 50 millimeters. That's actually extremely difficult to do. These samples are also only 8.5 inches by 9 inches. They roughly weigh, 10 to 11 pounds. They have different additives, so they tend to fluctuate in weight a little bit. And stopping one projectile is one thing. A cinder block can almost do that. But we're talking about multiple hits from a 308 in a 2-inch thick piece of concrete. That is where the difficulty comes. So let's go out to the range. Let's see what we can do. And bear with me, it was windy and cold, so the sound is a little muffled. I had layers on, but I did what I could to improve the sound. But let's get out to the range and let's see how we did.
Okay, so we're back at the range and we're going to do a little material science, a little terminal ballistics with kinetic energy. The one thing I love about concrete is that you can add all sorts of stuff inside of it. It's like baking a cake. You can add the ingredients that you want, and certain things make it more brittle. Some stuff should make it more ductile. Some should make it impact resistant. And that's what we did today. Today we got quite a few different samples. If we go way back to my initial testing, we were able to stop a 5.56 in 3 inches of concrete. So theoretically, 3 inches of concrete should be able, and this is just standard concrete, should be able to stop a 308. It just breaks up. So the whole point of this test is to see if we can get at least 2 shots of 308 in 2 inches and stop it. So let's set them up and we'll see. Okay, so like I said, we were going to be hitting these with a 308. These are 147 grain full metal jackets. And first up is our control. This, and what I forgot to mention also is we have clay behind it just to represent or see if anything passes through. But theoretically, this should stop the 308. We're not 100% sure, but it should also destroy that block. So let's go ahead, get our first shot in. And we'll go from here. So this is pretty much what's left. We went ahead and put this rubber mat on top of it. It hit right here, and whoa, it may have gone through. Okay, so we dug around a little bit and we actually noticed it did go through. It 100% went through. That's lead and jacket that's left. So, next one, we'll see if we can actually stop the 308. All right, here we go. That last one kind of proves our point. Without any additives or structural support, one shot and those things are done. This is our first one. This one we kind of threw what we had in the shop in there. It's got glass marbles, it's got nails, it's got steel fiber. Should hold up a little bit better, but still, this isn't quite where we want to get to. So, but let's go ahead and see how this one works, and we will go from there. Let's see if we can at least get 2 shots on this one. You good? Okay, here we go. Clear. Well, look at this. It stopped it. But let's see what damage it did in the front. That is colorful. So you can see a little bit of everything in here. We have marbles, we have some of these ceramic beads, small ceramic beads. Look at what I found right here. One of the nails. That's the nail that is in the back. But it did what it was supposed to, it looks like. Broke up the projectile in the front, propagated the energy, kinetic energy throughout, and stayed together. I'm not sure we're going to get another shot out of this one, but we were able to stop the 308 on this one. So let's move on to the next one. Okay, so this next plate up is basically more of a standard cement. It still is rapid set, which is about 10,000 psi of compressive strength, but we did put gravel in here and some scrim to hopefully get more than 1 shot. It also has fiberglass for reinforcement. So let's go ahead and we'll see if we get at least 2 shots out of this, or at least stop the projectile on this one. We're gonna go a little bit higher and hopefully get 2 shots out of this. Clear. Okay, walking up to this, it looks like it might have a little more damage. Maybe not. It held together better. But when it doesn't move, you can definitely see some of the jacket there. Uh-oh. It looks like we got a pass through. Let's check the back. We did not, which is why we have this here, just to make sure. No, nothing came through. It just displaced all its energy. Now guys, this is 50 millimeters of concrete, 2 inches of concrete. And we're gonna try to get 2 shots of 308 on this. All right, let's get 1 more shot. All right, second shot on the plate. Let's see if I don't hit it in the same spot. We're gonna try to go about 2.5 inches lower. Good? Yep. Clear. This thing is still held together, as you can see, but it's stopping the projectile, but it's leaving, or I guess I should say it's sending enough kinetic energy that this layer of scrim in the back, which is this fabric, is not enough to hold the concrete together, at least in the back. It's holding it together this way, just not in the back. So, as you can see, we were able to stop a second shot of 308 with this. Nothing went through. But this guy is taking some damage. 2 shots. Let's go on to the next build and see what we can do. Okay, that last plate was impressive to me because it's an easy build. It's an easy build to make. This one has 3 separate layers and some pea gravel and some other stuff inside of it. I think it should hold a little bit better than the last one. Well, let's shoot it and see. Clear. Okay, well, walking back here, it does not look like it went through. It dispersed a little bit more energy to the back, which is surprising to me, because I felt this one was going to hold better. Let's see what kind of damage it did to the front. Wow. It's a little windy today, but look at that. It did not crack that much at all. It did go a little bit further in there than I think I like, but it got stopped. There's very few cracks around this. So we're gonna go ahead and try to hit it right here. Make sure we can stop 2 shots of 308. Okay, second shot on this plate. See if it'll crack or hold together. Clear. Oh, well, that is interesting. Oh, that feels nice on a cold, windy day like today. I hope the slow-mo somehow caught this. It probably came out when it fell forward and it came out the inside here and landed there. Hopefully the slow-mo got that, but let's see what it looks like in the front. Oh my goodness, hold on. It did not go through. Again, that's why we have this here. But this one is transferring some energy to the back. That is a lot of energy. Granted, we're shooting from 15 yards and dodging some concrete shrapnel on the way, but wow. So I think what's happening is this netting in the front is keeping a lot of the energy from spitting back out. But what it's doing is it's sending it back that way. Because that's very little. Let me clean out the back. That's very little cracking in the front. Very little cracking in the front. It's quite a bit of damage in the back. But But for 2 shots of 308 from 15 yards, that's impressive. Okay, on to our next plate. Okay, so this is the one I'm interested about. This is our ultra high performance concrete. Has a simple mix, but the PSI compressive strength is up around 20,000 PSI. So let's go ahead, hit this, see what we get. Once again, we'll try to hit more towards the top. Clear! We got a little bubble in the back there. It didn't go through, as we can see here on the clay. I'll show. We remashed this. But let's see what it did to the front. Oh, interesting. This is probably the first one that didn't go all the way through. Huh. Okay. Let's see what we do when we hit it with 2 shots of 308. All right, here we go. Second shot on our ultra high performance concrete plate. Good. Here we go. Clear. Once again, we got a big ol' indentation in the back. Nothing went through. See how it did. Woo! There you go. So what I'm thinking is sometimes, just like metal and other things, the harder the surface, sometimes the more brittle it tends to be. This had quite a bit of material in it, but at 2 inches thick, that's still amazing to say. We're able to stop 2 308s. In that small amount of space. Don't see any of the projectile. So, okay, we're gonna go ahead and shoot the 2 1/4 inch one, but I have a good feeling it is gonna stop 2 rounds pretty easily, but let's give it a try. Okay, so next up we got the plate that's 2 1/4 inches, and yeah, it still has some stuff inside, so I think this one's gonna fare pretty good, pretty well, but let's go ahead and hit it and we'll see. Okay, let's try for the top half again. Clear. So you can see here on the side, these are the separate layers that we do when we're making it. And by stopping the kinetic energy to the back, it's got to go somewhere. So let's see, this one has little back face deformation. because most of it shot to the front. Which, if you're being shot at, is probably a good thing to have stuff coming back at whoever's shooting at you. That laid a pretty big hole, so let's go ahead and try to hit the 308 somewhere over here and see how it does. All right, here we go. Second shot, we'll try to go below that and a little to the right. Clear. Well, that is quite a bit of damage there. So what is the big difference on this plate is it doesn't have the scrim netting, and I think you could tell the difference now. While it is still being held together, holy smokes, did I see either the bullet or some of the jacket in there? Give me a second and see if I can do a little operation here. Oh, that is probably the littlest bit of jacket. Anyway, what that tells me is it didn't go all the way through. I don't think, so let's check the back. It did not. So we do have scrim in the back, and that is what's holding this back together. So at 2 1/4 inches, we are definitely getting better results. It also looks like this poly fiber is holding the front from cracking quite a bit. And you can see all that poly fiber next to the steel fiber. Woo! A little windy right there.
So, after a long, windy day of testing, what did we learn? Well, first, adding reinforcing fibers and water reducers greatly increases the strength and resilience of the concrete. And second is that layering concrete to have a specific impact-resistant layer and an anti-spalling layer greatly increases the effectiveness and efficiency of these thin concrete pieces at stopping higher-powered rifles. Now, where do we go from here? We take the best mixes, maybe modify them slightly, and start our modular ballistic wall panels. As the name implies, these will be modular panels that are UL Level 8 rated panels, able to be put up quickly or added to existing or new structures. Excited to get those out soon, so. Well, if you made it to the end, I greatly appreciate it. But don't forget to like, share, or subscribe. And until the next one.